So now that we're back to the main screen and the UPS is operating normally, we're going to begin with the UPS efficiency tests, and we're going to remove the battery source during this test, since obviously we have it in a charged state, so there's a decent amount of power going to that. And with the efficiency mode, we want to show you purely input power versus output power going into the UPS and out of the UPS, and show you how the system operates under those loads. So the first test we're going to be performing today is the overall system efficiency tests. We're going to be testing the efficiency at 0, 25, 50, 75, and 100% load on the UPS. In order to show this correctly, we're going to have batteries removed from the system, since we had a significant amount of charge current going to them. So the batteries will be disconnected. So I wanted to take a second and show you the main screen while the batteries are disconnected, showing you that the batteries are isolated, all the 5 power module statuses are still on, and power is flowing from the input of the UPS through the UPS to the output source, and not in any power conditioning mode. In addition, we have currently alarms telling us that our battery disconnect is open, as well as that the UPS is alarmed because we have battery disconnected. So from here, we're going to take a step over here to our AMEC power meters for demonstrating the UPS input power versus UPS output power. One thing nice to show at 0% load is the overall system parasitic losses without any load on the UPS. So showing you how much power is lost just from the UPS sitting idle. Currently, on our input, we have 7.76 or 77 kilowatts of total loss to our UPS with no load on the output. Another thing that's interesting to see is the overall harmonic content of the UPS output waveform voltage. Currently, on each of the 3 phases, we have about 0.6, 0.7, and 0.8% total harmonic content of the UPS output voltage waveform. So we're now going to increase the load to 25% and show you the losses of the UPS at 25% load. Good, Ed. So we've increased the output load to 500 kilowatts, or 25% of a 2 megawatt UPS system. We can see the output harmonic content really has not changed very much on the output voltage. But another interesting thing we can see is the input harmonic content of our converter. With 25% load on the UPS, we now have about 8% input harmonic current on each of the 3 phases of our UPS input. This means that 25% load, we're actually pushing very minimal harmonic content back out to your utility system, your generator, your air conditioning system. So that's very minimal content for 8% load. And that's due to our ability to provide active harmonic cancellation inside the UPS from the inverter, actively countering the input current harmonics from the converter section. Now let's take a look at our overall system efficiency. So now that the load banks have stabilized, we're at 499.5 kilowatts load. Clear that. 499.4 kilowatts load divided by 516.8 kilowatt input load for a total overall system efficiency of 96.63%. Next, we're going to increase our load up to 1 megawatt, or 50% of the UPS. Again, it's interesting to see the harmonic content of the output voltage waveform, very stable at about 0.5% harmonic THD on the output. And our input current harmonics are now down to about 4%. And we'll continue to see that decline as UPS loads up to 100% output load. Back to our input and output power here. We'll let this load stabilize a little bit. We can see we have 1.006 megawatts on the output divided by 136 megawatts on the input for a combined total of 97.1% UPS efficiency at 50% load. From here, we're going to increase our load up to 75% load. So 1.5 megawatts on a 2 megawatt UPS system. Again, we'll take a look at our input and output harmonic content. Our output is still declining down to about 0.3% output total THD on the voltage, as well as 2.7, 2.4, and 2.5 output total or input total current harmonic distortion. So as I said, it would continue to decrease as we approached 100% load to well within spec, and we're currently at 2.5%. Back to the output power on the UPS system. We're operating at 1.512 megawatts divided by 1.559 input megawatts for a total UPS efficiency of 96.98% or 97% UPS efficiency. Next, we're going to increase our load to 2 megawatts, so 100% load on the UPS. Now that the load is at 2 megawatts, we'll look at the output voltage harmonic distortion, still about 0.4, 0.3% on each of the phases. We'll also look at the input current harmonic distortion, let's say about 1.8 to 1.9% input total harmonic distortion of the current. Again, very low and well within spec on the UPS. Back to our power ratings, we can see we're at 2.014 megawatts divided by 2.081 megawatts. So about 96.78% or 96.8% efficiency at 100% load. We really appreciate you watching this video, and if there's any questions, feel free to reach out to us and we can provide more detailed discussion on any of the topics that you saw today.